Hello everyone, welcome to this one-shot review of Unit 3, Differentiation for AP Calculus AB as well as BC. In this video, we will be covering key techniques of differentiation that you can see here, composite, implicit, and inverse functions. This is simple, but it needs consistent practice. So let's dive into this. First is the chain rule. The chain rule we will be actually using for composite function. So now we have a quick recall of what is composite function. Composite function is something look like this, f of g of x. Okay, f of x we know, g of x we know, but the function f takes another function as an input, right? So this is what composite function is. And here we have an example, sine of x squared. Usually sine x is a function, but instead x I have another squared function over there. So that is, and square root of ln x is another composite function. Now here you need an important skill. What is f and what is g? If sine x squared can be written as f of g of x, then your f is sine x and your g function is x squared. So you just go from outwards to inwards. That's simple. F g x. So f is sine, g is x squared. And this one you can solve. F is outside function is square root, so root x, and g is ln x. That's simple. Yes, we will be dealing with three composite function also, three functions which is composed. And here is an example which looks like f of g of h of x. And you can see an example here, sine of cos of 5x. So your f is sine, your g is cos, and your h is 5x. This is the only prerequisite that you need. Now, how to apply the chain rule? This is the chain rule formula. D by dx of f of g of x is f dash of g of x times g dash of x. So you have to continue the chain. First, you just differentiate the function as it is. And then by multiplying the input derivative. So input is g of x, just multiply by its derivative. That's simple. And this you can even continue it for three composite function also. Let's take an example. Find the derivative of f of x, x squared plus 1 the whole cube. You don't want to expand here and simplify. Our chain rule will help because here the outside function you can take it as cube function, inside function is x squared plus 1. So yeah, chain rule is valid. Okay, how should I apply? First, you just work on this derivative, x squared plus 1 the whole power 3. It's just a power rule. You just treat x squared plus 1 as just an x, right? So how will you do? Apply the power rule, multiply 3 in front and keep the base as it is. We are not touching it, and reduce one exponent. Okay. Now you continue the chain by multiplying with input derivative. What is your input? Instead x, I have x squared plus 1. Its derivative is 2x plus 0, which is simply 2x. That's simple. Rest you have to simplify. Right. So 3 into x squared plus 1, 3 power. So actually this is what we did, right? 2x and 6x into x squared plus 1, the whole square. That's simple. And one more example for you. 1 plus cos 2x the whole square. So let's derivate it. dy by dx is, okay. So 1 plus cos 2x is just the base. You treat it as a base something, right? And 2, how will you apply the power rule? You will multiply 2 in front and you will copy the base and you will subtract 1 from the exponent. That's it. But we should not leave here because input is not just x, it's something other than x. So next you have to multiply by the derivative 1. If you derivate it, 0. And for cos 2x, it's minus sine 2x. Then you should also derivate the input because sine 2x, what is the derivative of 2x? It is 2. Here we apply double chain rule, right? So I derivate the input 1 plus cos 2x, that is 0 minus sine 2x, and I have derivated the input 2. So that is important. And simplified, 2 and 2 will go 4, 1 plus cos 2x minus sine 2x. We can simplify it further. That's the thing. Now into the next topic. Next question, given the following table of values, find f dash of 4 for each function. You are not given any expression, just table of values. And f of x is g of x the whole square, right? we need to find f dash of 4. Okay, so how will you differentiate? Simple. F dash of x is, if it's a power, apply the power rule. 2 times g of x whole power 1. Then you will, the input is g of x, right? You will derivate it. That's it. So this is your f dash of x. Now you know the rule. If you want f dash of 4, it's 2 times. Just plug in 4 wherever x comes up. And you have all the values here. This is your x. So this is your g of 4. Let me give you this. So g of 4 is, this is g of 4 and this is g dash of 4. From that, you can plug in those values and simplify. Same here. H of g of x. So f dash of x is, first you will derivate the outside function, then multiply inside stuff, you will derivate it. And we need f dash of 4. So just plug in 4 wherever x comes, h dash of g dash of 4 times g dash of 4. And what is h dash of g of 4? So we have to plug in what is g of 4 first. G of 4 is, this is your 4 and g of 4 is 3. So you have to put 3 here and g dash of 4, we got 3. Sorry, g dash of 4 is minus 2. So minus 2 here. And then find h dash of 3. This is 3. This is h dash of 3, which is minus 2 times minus 2, which is positive 6. This is the way we can solve. Without an actual expression, in function notation itself, we will be dealing with some problems. That's simple. Now into the second topic. Implicit differentiation. It's a very important thing. Let's get into this. First, let's see what is explicit and what is implicit. Explicit, it makes more sense. Like one variable is expressed in other form. For example, y is equal to 4x minus 1. This is explicit form. Y is completely expressed as y in one side, completely x is on the other side. So this is actually most of the times we come across. Implicit form is something like this. X square plus y square equal to xy. Something kind of equation, x and y got mingled. It's not like one variable in terms of the other. Now, how to apply this implicit differentiation? Before that, we have to connect chain rule and implicit differentiation. So we know d by dx of x is just 1. Actually, sorry for it. Actually, it's just 1, right? But instead x, I have y. You have to differentiate y with respect to x's. It's not 1. Okay, so it's dy by dx. This is the one important thing we need to understand. Now, what if it's x square? I will apply the power rule because my input is made up of x. I am also differentiating with respect to x. So you can apply the rules and the formulas you have looked. But the same thing, if I have an y square, you can still apply the rule, like power rule you can apply. But the thing is chain rule. So 2y you have applied. Okay, what about this y? Y is something made up of x. So we have to differentiate that into dy by dx. The same thing we did here. When you differentiate y, it's 1. But y is a function. Y is not, I'm not sure, is it y sine x or y is e power x? We don't know, right? So for that, we have to do this chain rule, which is dy by dx. Apply the chain rule. Then here, d by dx of ln 2x. What I will do, I will reciprocate the function. Then I will apply the chain rule and 1 by x, right? 1 by 2x. Then you have to derivate the input and that becomes 2. Simplifying, it's 1 by x. Now, if you have y, yeah, you do the same thing. Reciprocate, apply the rule and the chain rule and one more chain rule for this y. It's not just 2, it's 2 dy by dx. And simplifying that, you will get 1 by y dy by dx. This is the place we should be careful in implicit differentiation, right? When you're solving about x, no need to worry. When you're solving about y, make sure you're applying the chain rule over there. Now, implicit differentiation, you have to keep these things in your mind. Differentiate. When y involved, use chain rule. When x involved, do it normally. And then after that, your expression will have dy on dx then and there. So you have to group them, collect them on one side and make dy by dx as a subject. That's the simple thing. Here we have an example. Find the derivative of x square plus y square is 1. Okay, first term is easy. Take an expression. First term is just 2x because it's only made up of x. I will apply the power. That's it. No chain rule. And second term is y square. Okay, terms it made up of y. So apply the power, which is 2y. Then this input is y, not x. So when you derivate it, dy by dx and equal to 1 differentiation is 0. So this is the place we have to be careful. That's something new to us. And you just simplify 2 dy by dx equal to minus 2x. We need dy by dx equal to minus 2x by 2y. And we got this. That's a simple thing. Moving to next, one more example. Find the values of x square y plus y square equal to 5 at y equal to 1. Okay. Actually, it is find the values of dy by dx. Find the values of dy by dx of this function, of this expression equation at y equal to 1. So x square y plus y square equal to 5. First, let's differentiate, and you know one thing. Here we have to apply uv. This is a function u, and this is v. So first differentiate that 2x and y as it is, u dash and v as it is. Then dy by dx into x square. Then 2y dy by dx equals 0. So implicit differentiation applied. Then 2xy plus dy by dx you take common, x square plus 2y equals 0. And you have to make dy by dx as a subject. So take 2x over there, it will go minus 2xy, and this will go to the denominator. This is why dy by dx. Now, actually in this case, we need to find the values of dy by dx when y is 1. Okay, but my dy by dx is, okay, I can plug in y is equal to 1, right? But, wait a minute. We can plug in y equal to 1. But what is x? So let's find x. It's simple. You just plug in this equation. That's the next thing. When y is 1, what is x? You have an equation which have x and y together and plug in y. You just simplify and you got x square equal 4. X is equal to plus or minus 2. So dy by dx, when x is plus 2, y is 1 combination. And it's very simple. We have dy by dx, right? So I can directly go to that. And plug in minus 2 by 3. Another combination is I also got minus 2. Then also y is 1. So you just plug in and 2 by 3. That's it. So your x values are plus or minus 2 by 3. So this is how the implicit differentiation problem for the test prep we can expect. And differentiating inverse functions. Okay, let's quickly recall what is inverse. If your f of x is x squared, the inverse is root x, right? Addition means minus, multiply means divide, something like that. So which will undo the given function. And basically how we will find the inverse of a function is by interchanging x and y. So f of x is a function, the notation is f inverse of x. If g of x is the inverse of x function, g of x is the inverse of f of x. G of x is f inverse is notation. We can say like this. And also this inverse and composite function. So you're compositing an inverse and the original function, you will get the input. Either way, you just go with inverse, like original function, then inverse, or composite, inverse, and then original. Whatever you do, when you're composing a function and its inverse, you will get the input. That is just x. So these are the ways which will describe the function as inverse. Now, how to derivate the inverse function? D by dx of f inverse of x is, this is the rule, 1 by f dash of f inverse of x, right? Okay, so 1 by f dash of f inverse, f dash and f inverse, they got composed. Let's understand this example. D by dx of ln x is 1 by x, we know. Actually, I'm gonna apply the inverse differentiation here. We know d by dx of f inverse of x is this, right? So my f inverse of x is ln x. So wherever f inverse comes, you use ln x, right? But f dash of ln x, how can I find f dash? Don't do ln x is differentiation is 1 by x. You should not do that. It's not equal to 1 by x, right? So next is f inverse of x. Here we go. To find f dash of ln x, f inverse is ln x. And what is f of x? It's e power x. We know that, right? They are inverses of each other, e power x. Then you find f dash of x. It's also e power x. And then you just find f dash of ln x. This is the way we need to do. You should not differentiate the input, right? So f dash of ln x is e power ln x. And now you can plug in. E power ln x means what? E ln, they are inverses, they will get cancelled, it's just x. So that's the case we got. D by dx of ln x is 1 by x. It's something like we just learned as a formula, but this is how we are describing it. We are deriving the derivative. Right. So test prep question, something like this. H is equal to G inverse of x. Find H dash of minus 1 and H dash of minus 3. This is the table given to us. Okay. What is given? Let's solve one by one. So x, g, and g dash. Solution. So first you write h is equal to g inverse of x. So h dash of something we need to find. H dash of x is 1 by, if it's an inverse function, g dash into g inverse. That's the formula we learned, right? And h dash of minus 1 is 1 by g dash of g inverse of minus 1. We are just plugging minus 1 in terms of x. And what is g inverse of minus 1? So this is your minus 1. Right? We got a minus 5. So I know this is g of minus 1. But what is g inverse of minus 1? You have to check in a reverse way because this is your input and this will be your output. Right? So g inverse of minus 1 is in g you have to go for minus 1 because it's exchanging, right? If this is your x and this is your y connecting g, then y will be your input in g inverse function. This is your g inverse of x, right? From this to this we have to go. So minus 1 means it's minus 5. That's how I got g inverse of minus 1 is minus 5, right? Just go in a reverse way. And g dash of minus 5, this one, x is minus 5. What is g dash? We will check that. It's minus 3. So 1 over minus 3, which is minus 1 by 3. One more example. H dash of 3, same thing. What h is g inverse of x? I know the inverse notation. H dash of x is 1 by g dash of g inverse of x. And we need minus 3. So h dash of minus 3, just replace x with minus 3. And g inverse of minus 3 means what? In g, you have to go. You have to go for the output and then the respective input. Right? So 1 by g dash of minus 4. And g dash of minus 4, it's simple. When x is minus 4, what is your g dash? So this is the thing, which is minus 5. So 1 by minus 5, which is minus 1 over 5. That's simple. Next one, differentiating inverse trigonometric functions. So d by dx of sine inverse, cos inverse, secant inverse, cosecant inverse, tan inverse, and cot inverse. What if I have an inverse form? Yeah, we can do the derivation part. Let me help you with the formulas now. First, you just memorize these stuff. The left side, which is 1 by square root of 1 minus x square. 1 by square root of 1 comes first, then minus x squared. When it is secant inverse, 1 divided by modulus x square root of x square minus 1. When it's tan inverse, it doesn't have any root at all. Tan will not have any root. 1 by x squared plus 1. Now, if you memorize this, cos inverse, like sine and cos are co-functions, right? It will have a minus. The same thing as sine inverse, but have a minus. And cosecant inverse also same. Same thing as secant inverse. They are also co-functions. Secant, cosecant, minus 1. And this also same. Tan, cotangent. So this will be minus 1 by x squared plus 1. That's the way you can memorize this. So just go with this and then you can start applying and make sure it's not x square minus 1. It's 1 minus x square for sine. Right. These are the derivative rules we can apply wherever we are encountering the inverse function, and also you have the notation something like this, arc. So it means cosec inverse x power 6, right? So let's find the derivative of a inverse function, inverse trigonometric function. We know d by dx of cosec inverse is minus 1 by mod x square root of x square minus 1. But instead x, I have x power 6. No problem. Just replace every, like your formula have x. Now it will be replaced with x power 6. X power 6, x square means x power 6 whole power 2, x power 12. Then chain rule times 6x power 5. Your input only you have to differentiate. So 6x power 5. This is an important thing. And you need to simplify minus 6x power 5. Mod x power 6 is just x power 6. That square root stuff will be as it is. And you simplify minus 6 by x. Like we are combining the powers, right? And x into square root of x power 12 minus 1. That's a simple thing. Right. Next is 3.5, selecting procedures for calculating derivatives. Okay, we learned a lot of techniques, right? In unit 2 itself, power rule, then constant multiple, sum or difference, right? Then we learned trig function, sine, cos, and logarithm, exponential. These many rules we have learned, right? And in this unit 3, we have learned these product rule, quotient rule, chain rule, implicit differentiation, like chain rule, implicit inverse. So these many we have learned in unit 2 and 3 combined together. So how to approach a problem and what rule to be applied. Find the derivative of ln 3x into 5 power 2x. So I can clearly see two functions have been in product, right? So ln 3x is your first function times the product rule. I guessed that, right? And you take u, we know the formula, it's u dash v plus v dash u. What is your u? It's your wish. I'm taking in order, ln 3x, and v is 5 power 2x. Then you differentiate. How will you differentiate for ln function? Just reciprocate. And if it's not just x, you have to apply the chain rule. So 1 by 3x times 3. Because input is 3x, that is important, and it's just 1 by x again. For v dash, any power function, you will copy the function times ln of the base. 5 power 2x, I copied ln of the base. And the important thing is, it's not just x, it's 2x. So apply the chain rule, like 2x differentiation is 2. Simplify it. And applying all those stuff, u dash v. U dash is 1 over x times v is 5 power 2x plus v dash is 2 ln 5 power 2x. When you're writing these things, make sure you're giving the appropriate symbol. For multiply, just a dot, or even multiply sign will be, so that you won't confuse with your work. Times ln 3x. That's it. And simplify this one, 5 power 2x by x, and 2 ln 5 ln 3x into 5 power 2x. That's the thing. Now, 3.5 is calculating higher order derivatives. So far, we have learned one derivative, like taking a derivative. Now, there is more derivatives. You can do second derivative, third, fourth, fifth, and so many, right? Till nth derivative. This is the notation. If your function is y, first derivative is y dash. Yes, second derivative is a much helpful one, which is y double dash, right? If it's an nth derivative, you just mark y parenthesis and the number, whichever derivative we are working on. And for f of x, it's f dash, f double dash, f nth derivative of x. For y, we are using this also, dy by dx, d square y by dx square. You notice one thing, it's not dy by dx the whole square. D square y by dx square, dn y by dx power n, right? And this second derivative is very simple. You know the first derivative, right? So first do that. Y is equal to root x plus e power 5x. Square root x is x power half plus e power 5x, and differentiate it. Apply the power rule. It's just a sum, so no worries, right? Half x power half minus 1. And e power 5x into 5. Make sure wherever you need to apply chain rule, do that. And simplifying this, we got y dash. But I need second derivative. Now you have to derivate from this. Now you apply the differentiation for y dash. That's the thing. So y dash is this, and y double dash continue power rule half as it is because it's a constant. And x power minus half, if you apply differentiation, minus half by minus half x power minus half minus 1. And plus 5 e power 5x, if you apply the rule, e power 5x into 5 and simplify. You will get minus 1/4 x power minus 3 by 2 and 25 e power 5x. That's simple second derivative. If you want third derivative, you just apply uh, the differentiation for the y double dash, right? And that's the thing. Now, one more function. For implicit differentiation, also we need to find second derivative. X plus y equals sine y. First derivative, you just go in order. X plus y sine y. X is just 1. Y is dy by dx. Sine y, first do the differentiation cos y. And since my input is not just x, apply the chain rule. So dy by dx. Right? Then you have to group the like terms. Dy by dx. So I'm taking the left dy by dx to the right, and I got something like this. Dy by dx cos y minus dy by dx. Now your aim is make dy by dx as a subject. Dy by dx cos y minus 1 and dy by dx is 1 by cos y minus 1. That's it. You need to differentiate this part on both sides. So dy by dx is this. You can write it as cos y the whole power minus 1 and you apply the chain rule because whole raised to the power is a function. Cos y minus 1 is another composite function. Now apply the chain power rule minus 1. And you know what? When you differentiate the left side, it becomes this notation. D square y by dx square. Because I'm going to differentiate with respect to x. This is what it means. Then dy by dx. When you combine d square y by dx square. That's the thing. And apply the power rule minus 1 cos y minus 1. Reduce one power. This power rule is a simpler one, right? Times, make sure you're differentiating the inside stuff, which is minus sine y. And this is also not just x. So for that, you have to again apply. So make sure you don't stop here. For that, you have to do dy by dx and simplify. I got sine y by cos y minus 1 the whole square dy by dx. You should not leave the answer. If they're asking for second derivative, it should depend upon again x and y only. So this we need to work on. You already solved it, right? Dy by dx is this, and you just plug in over there. And you will get sine y cos y minus 1 the whole square times replace dy by dx with the function and simplify. So this is your final step. Right? So second derivative with implicit differentiation. Done. And that's all the review for Unit 3. Yes, it seems like simple, but it is an effective one. You need a consistent and you have to do a lot of practice, I would say, so that you will be very quick in solving and you can save your time. So you're stepping up in your skills and your differentiation mastery had been achieved. Thanks for watching with Let's Unbond. We can meet in another video very soon with yet another interesting review. Thank you so much for watching. Keep learning and keep practicing.